As we all know, the development of the network goes so fast that more and more people are starting to use wireless networks. However, in wireless networks, a packet loss can be caused not only by a real congestion, it can also be caused by the noise in the radio channels. In this way, if we regard the packet loss as an indicator of a real congestion in the network, it is not totally right. However, as for the most widely used TCP variant, which is called cubic, it does not have the mechanism to decide whether the packet loss is because of a random loss or a real congestion. In this, every time it encounters the packet loss, it will just deduct the congestion window by 30%. Therefore, as you can imagine, if the random loss rate is very high, it will always deduct the congestion window and it almost can't utilize the bandwidth. In this way, my final year project is to implement a new TCP variant, which is called Cubic Plus, to improve the performance of it in wireless networks. It is implemented based on Cubic, but also added some other features that I get from other sources. Now here comes to the methodology. I mainly use four kind of mechanisms in my algorithm. The first one is cubic growth function. It is inherited from the original cubic. Every time it deducts congestion window after a packet loss, it will not increase the congestion window linearly. Instead, it will use the cubic function to increase it. In this way, as you know, a cubic function can grow much faster than a linear function, so it can improve the performance of my algorithm to make it fully utilize available bandwidth much faster. As for the second one, it is the high start mechanism of detecting what is time to exist the slow start phase. High start is an improved version of TCP cubic and the original cubic. In the slow start phase, it will use the exponential function to increase the congestion window. And at the exist point, since the exponential function grows so fast, at that point, there will be a large number of packet loss and retransmission. High start has a mechanism to improve this. It, it can detect whether the congestion window is going to be equal to the BDP, and then it can make the algorithm exist to the slow start phase much more smoothly. The third mechanism is the estimate bandwidth mechanism that I get from TCP Westwood. It will continuously monitor the rate of returning X to calculate the sample throughput. The sample throughput, together with the estimate bandwidth calculated last time, are the two inputs to a low-pass filter, and the low-pass filter will be passed twice to smooth the output. However, there will be a problem in this mechanism that since the sample throughput will be counted for only a small part in the low-pass filter, it will grow very slowly. And as for the last one, it is the most important one, is the random loss detection mechanism that I get from TCP Vino. It chooses the difference of the actual throughput and expected throughput to decide whether the packet loss is because of a real congestion or just a random loss. Based on many experiments, it will set a constant value for the threshold of the difference. If the difference is smaller than the threshold, then it decides the packet loss is just a random loss. However, if the difference is larger than the threshold, it means that there is a real congestion in the network. After knowing these four mechanisms, first I want to talk about the things I did last semester. First I'll talk about, let's see the pseudocode. I mainly changed the big TCP recalculate as a threshold function. If it detects it is a random loss, it will return the congestion window to be the maximum value of the estimate bandwidth and the original CWIN, so it will not deduct the congestion window. However, if it is a real congestion, it will just return the congestion window to be the maximum value between the estimate bandwidth and the deduct by 30% value. Last semester, I did all the things in simulation, and I found everything performs well. However, this semester, I re-implement all the things in Linux, and I found some problems. But when I was doing emulation, the first problem is the cubic function continuation. First, I want to mention is that in the original cubic, every time it encountered the packet loss, there will be a there will start a new epoch of cubic function. Since I have changed the return value of the congestion window, it also changed the input of the cubic function. So it will not start from the lower point of the cubic function. It will just start from the middle point of the cubic function. So it will be very flat. So as you can imagine, if the random loss rate is very high, it will always add the flat point, which is shown in the first figure. In this way, I found the most important parameter that can set the start of set the end of an epoch and start a new one. So I changed this equation to the case of real congestion instead of in every packet loss. So the result is showing the second figure that I can, if it is a random loss, it will continuously to go as the original cubic function. The second problem is the exit slow start phase problem. As you can see from these two figures, in my 10 test cases, there are always some flows that will exist the slow start phase very early. This is because in original slow start phase mechanism, when it encounters the packet loss, it will exist the slow start phase. However, in my aim, if the packet loss is a random loss, we should not exist the slow start phase. In this way, I found the mechanism of high start because I have mentioned before, high start can detect when to exist the slow start phase. So I add the flag to indicate whether it is time to exit. First, this parameter is equal to 0. Only if there is a real congestion happens or or there is or high start detect that it is time to exit the slow start phase, the flag will be updated to 1. And after it is 1, it will exist the slow start phase. Here comes to the result and conclusions. To test the performance of cubic plus, I I did other experiments in EmuLab, which I can do some emulation. Here is the topology of my mechanisms. The left side is the client, the right side is the server, and in the server I installed Apache server and downloaded several fixed size packets. As for bridge, I used the Dominet to set the network configurations. In each experiment, first I set the TCP variant I want to use in the right server, and then in the client I use wget to fetch those fixed size packets, and I will record the completion time. I did this experiments mainly in 3G and 4G cases, and I try different random loss rates. And the results in the following tables are the average FCTs of 10 experiments. As you can see from these tables, the higher the random loss rate, the better the performance of cubic plus comparing with other TCP variants, since the average FCTs is much less than the others. Also, my algorithm can really make some improvement to the case in the wireless networks. I also experiment the fairness of my cubic plus. The network setting is 30 megabit per second and 0.1% random loss rate. As you can see from these two figures, no matter the other flow starts at which time after the first one, finally they can always fair share the bandwidth. In this way, cubic plus is fair to itself. As for the future direction, since last semester I did all the things in simulation, this semester I did all the things in emulation, but all these things are the things that I can configure. But for the future, but they are not the same as the things in the real network, so I really need to test it. And here are the references, but not all of them. And finally, I want to show my appreciation to Professor Jackley and the TA. Thanks.